Welcome to lesson number 4, equations and intercepts from the vertex and a point. So what we want to do here is we want to be able to determine the equation if we're only given the vertex and a point on our graph. So the first thing we're going to do is follow these steps. So step 1, step 2, step 3, and step 4. So for step 1, we want to replace P and Q with the coordinates of our vertex. And remember that these points, P and Q, refer to the equation in standard form of our quadratic function, which is going to be y is equal to a times x minus p squared plus q. Okay, so using our standard form equation, we are going to try to find out what this equation of the function is going to be. So first we'd replace p and q with the coordinates of the vertex. Next, we'd replace x and y with the coordinates of the point. We would solve for a, and then replace all those values of a, p, and q back into our equation. So let's start. The graph of a quadratic function has a vertex -2 and 8 and passes through the point -1 and 7. And so first of all, let's list what our vertex is. Our vertex is -2 and 8. And that means that our p value is going to be -2, and our q value is going to be 8. So if we plug this into our equation, we're going to have something that looks like this. Y is equal to a times x plus 2. If we put this back into our equation, this -2 will make this negative a positive, and it's going to be plus 8. Okay, so that's our first step, and we replaced p and q with the coordinates of the vertex. Now we need to replace x and y with the coordinates of the point. And so the point that we were given in this question was -1 and 7. So we're going to replace that with the x and y. We're going to replace x and y with this point. Okay, so y is going to be 7. X is going to be -1, and then we had p and q, which were -2 and 8. In this case, it's going to be +2. So we solve for a. That's the next step, is to solve for this a. And so if I'm solving for a here, that's going to be equal to 7. A -1 plus 2 is just going to be 1 squared plus 8. If I square the 1, I'm just left with 1. So this is going to be 7 is equal to a plus 8. If I get rid of this 8 by bringing it to the other side, I have to subtract 8 on both sides, and I'm going to be left with a is equal to -1. Okay, so then what we do is, once we've solved for a, we now have to plug all of these back, replace the values of a, p, and q into the equation. So our equation being in standard form, that means that we're going to have y is equal to a x minus p squared plus q. We'll plug all those equations back in. We're going to be left with y, or all those coefficients back in. We're going to be left with y is equal to a -1, which would be -1 x plus 2 squared plus 8. And if we're left with a -1 there, then we're just going to express this as -x plus 2 squared plus 8. And this would be our final answer. Next thing we want to do is rewrite the equation in general form. And so you might remember general form from the last few units, hopefully. And general form is written as y is equal to ax squared plus bx plus c. And so if I'm starting with y is equal to -x plus 2 squared plus 8, if I were to expand this middle part of my equation, I'm going to be left with y is equal to x squared plus 4x. 2 times x times 2 would be 4x, and 2 squared would be 4, and then we're going to add 8 to that. And so I can just combine these terms here, but remember, this negative is going to impact not only this x, but this 4 and this 4 as well. So what we're going to be left with then, when we get rid of those brackets, is negative x squared minus 4x, subtract 4, plus 8. So our final equation is going to be negative x squared minus 4x plus 4. This here is our final answer. Now, this last question, using a graphing calculator to sketch the graph and determine the x and y intercepts of the graph of the function, and then answer to the nearest hundredth if necessary. So this is the equation that we need to plug in. It's going to be negative x squared minus 4x plus 4. We're going to graph this, and we need to find where our x and y intercepts of our function are going to be. So first things first, our x-intercept is going to be, if I find out where those zeros are, guess down there, guess here, and I have one of my x-intercepts at 0.83, 0.83, and my other one is going to be on this other side down here. And so let's see what that exact value is. And it looks like my next point is at negative 4.3. Negative 4.83, sorry. And we're also looking for our y-intercept of the function. So if we're looking for that, we can just type in, what I did there was I went to value. So again, second function trace, value when x is equal to 0, our y-intercept would be 4. So that's where this crosses my y-axis. Y-intercept is equal to 4. Oh, and you know what? I forgot to draw my graph. So I should probably do that. Alright, so this is my graph. One thing you can do if you don't want to find out where those actual values are, you can go to the table, your table of values, and you can see here that I have them all listed for both my x and y axis. And so I like to start at thinking about where my vertex is going to be. And we already determined where our vertex was. That was at negative 2 and 8 to begin with. And so it's going to be at negative 2 and 8 about up here. And then if that's where my vertex is, negative 2 and 8, I'm going to move down from those one each time. Okay, so negative 2 and 8, and then I'd be at negative 1 and 7. And then I would be at negative 1 and 7, negative 2, and oh wait, where's this going? Well, anyways, we're gonna open it up down here, and that's generally what the graph is gonna look like. Very similar to this. Of course, these Windows settings need to be adjusted a bit. So here, if you want to count what your Windows settings would be, you can go ahead and do that. But I'm just going to move on to the next question. So we can use the equation of a quadratic function written in standard form to algebraically determine the x and y intercepts of the graph of the function. So what we want to do is determine as exact values. So if you remember what exact values are, these are values that they are not expressed in decimal form, but they have to be expressed as a radical, fraction, or whole number. Okay, so these are exact values. We need to find out what the x and y intercepts of the graph of the function are going to be given this function. Okay, so first let's think about what that means. If we're looking for the x-intercept, that means that y is going to equal 0, right? So if we're looking at this graph, anytime we have an x-intercept, it means that our value of y was 0, right? It didn't go anywhere up the y-axis. When I was looking for my y-intercept, then my value of x was 0, right? Because it's not moving from this middle line here. Okay, so what we're going to do is we are going to set each of these equal to 0. So let's first solve for our x-intercept when y is equal to 0. And so if y is equal to 0, I'm going to set this as 0, 3, x minus 1 squared minus 9. And now all we need to do is solve for x. So to do so, I'm going to bring this 9 to the other side to balance out my equation. 9 is going to be equal to 3 times x minus 1 squared. If I get rid of this this 3 here, I'll have to divide by 3. If I divide both sides by 3, I'm going to be left with 3 on this side and x minus 1 squared. Now I need to get rid of the square root. Now, in order to get rid of the square root, I'm going to have to take the square root of both sides. So if I take the square root of both sides, that's going to leave me with the square root of 3 is equal to x minus 1. Now I need to get rid of this one here, and so to solve for x, we are going to have, move up here, but if I add 1 to both sides, we are going to have 1 plus root of 3 is equal to x. But since we don't know that if we're looking for the square root, this could be plus or minus both ways, right? Because if I bring the if I were to solve it the other way around, then we could potentially have a plus or minus being rad 3 to give us rad 3. And because this is a quadratic function, we know that there's 2 points on the x-axis. Okay, so it can be plus or minus rad 3. And this would be our final answer right here for our x-intercept. Now let's think about our y-intercept. Okay, so when we have a y-intercept, that means that x is equal to 0. And so in our original equation, we're going to set every x in our equation equal to 0. 0 minus 1 squared minus 9. And so 0 minus 1 is going to be negative 1. And if we take the square negative 1, this is going to be equal to 3 times 1 minus 9. And so 3 minus 9 is negative 6. Y is equal to negative 6. And so there we have our x and our y intercepts. Next, we want to the graph of the function is shown here. The maximum point is shown to be negative 1 and 2. So that's the highest point on the graph. That's what we call the maximum. And we want to find the equation of the function of the line. So we have a point and we have our maximum point, which also happens to be our vertex. All right, so let's start with our vertex. That's going to be negative 1 and 2. And we also have the points negative 3 and 1. And these are going to be x, y values that will plug into our graph. Okay, so y is equal to ax minus p squared plus q. This is our standard form, and we want to find out what this equation is in standard form. So all we need to do is plug what we have into our graph, or into our equation. So y is equal to ax plus 1. I'm bringing this 1 back in, squared plus 2. And now what I want to do is I want to plug in these points of negative 3 and 1 into this equation. So my y value was 1, and that is equal to negative 3 plus 1 squared plus 2. So negative 3 plus 1 is going to be negative 2. Squared would be 4. So negative 2 squared is going to be 4a plus 2. When we solve for 4a, we're going to have to bring this 2 to the other side, which will leave us with negative 1 is equal to 4a. And divide by 4, we're going to have negative 1/4. So a is equal to -1/4. And now we got to plug that back into our equation. Our original equation of y is equal to a x minus p squared plus q. So that's going to be -1/4 x plus 1 squared plus 2. And now to find algebraically the x-intercepts and y-intercepts of the graph. Answer both as exact values, just like we did up top there. So exact values and to the nearest hundredth. Okay, so remember, if we're starting with our x-intercept, that means that y is going to equal 0. Okay, so 0 is equal to -1/4 x plus 1 squared plus 2. That's the equation we came up with up here. We're bringing it down here, and we have to fill in what we have. Okay, so one thing we do, if you don't want to work with a -1/4 value, you can bring this whole part of the equation to the other side. So I'm essentially adding this part of my equation to both sides, which give me -1/4 x plus 2 squared, and that's equal to 2. Now what we can do is get rid of this -1/4 by multiplying by 4 or dividing by 1/4, whichever one. It'll be the same thing, and you'll be left with x plus 2. Oh, how did I get that 2 there? That should be 1. X plus 1 squared, 2 times 4, or 2 divided by 1/4 is going to be 8. And now remember, we need to take the square root, and if we're square rooting 8, we're going to end up with plus or minus 8. So x plus 1 is equal to plus or minus rad 8. Since we don't know if it was two negative numbers that multiplied to give us rad 8, or if it was two positive numbers. That's why it can be either one. And then if we solve for x is equal to -1 plus or minus rad 8. And remember, if you think back to radicals, we can also express this as x is equal to -1 plus or minus -4 times -2, or 2 rad 2. And this would be our final answer for our x-intercept. Now for our y-intercept, remember, with our y-intercept, that means that x is equal to 0. Right? X is equal to 0 in this case. So that's what we're going to do. We're going to set our x equal to 0, 0 plus 1 squared plus 2. And if we do that, 0 plus 1 squared is just 1, so we'll be left with -1/4 plus 2. -1/4 plus 2 is going to give us a y-intercept of 7/4. All right, you can do this in your calculators quick, or you can do it in your head, but -0.25 plus 2, and we don't want to leave it as a 1.75. We don't want to leave it as a decimal, so we want to express that as a fraction. Next thing we're going to do is state the domain and range and the equation of the axis of symmetry. So our domain, it's going to look something like this, right? This is what our graph actually looks like. And so our domain is going to be all real numbers. Domain is x is an element of real numbers, because our x is going all the way along, so all the way between -5, or between these points, covering all of these x variables. Our range, if we are starting here at 2, then our range is less than 2. It can't go greater than 2. So that means that our range is going to be y is equal to or less than 2, than our maximum point on the graph. And those are also all elements of real numbers. And if we look at where our equation is on the x-axis, our axis of symmetry is going to be x is equal to -1. Of symmetry, x is equal to -1.